Hello, I'm Joel Chatfield, and this is Physics Lab 1 Charge Tape Lab. So the purpose of this lab is use tape to show how objects of different charges interact, as well, and then we're going to simulate those interactions with GlowScript and calculate the charges of the tape and the force interacting on it. So basic concepts we're going to use are Coulomb's law, which is shown on the right, specifically that top interaction in which like forces like charges will repel each other. Then we're also going to use Newton's second law, and we'll use that to calculate why something floats. And then lastly, just basic electrical fields. So the experiment. So the system of our experiment is two pieces of tape, which we've given positive charges, and then rapidly separating them and using the positively charged tape whose electrons have been left on the other piece that we discarded. We confirm they are positively charged by negatively charging a pen via rubbing it across like fabric and hair and then making sure they're attracted to each other. And then we know that the tape B is positively charged because after checking the charge of tape A, they repel each other. So just some basic numbers. Tape B was repelled 0.0244 meters. The mass was 0.0002 kilograms, so gravitational force is 0.00196 newtons. And now we can calculate the charge because we know the electrical force must be directly opposed to the gravitational force, so we're going to use that Coulomb's law equation. And we're assuming that the charges on the tape are the same. So like I said, we're going to use Coulomb's law, and when we solve it, we get 1.137 e to the negative 8 coulombs to be the charge of the tape. And then here we just have the GlowScript math. Just some basic numbers at the top. Down at the bottom is actual equations. Then on the left is the demonstrated forces. So that orange arrow is going to be gravitational force. You see it's proportional to the electrical force up on the tape. And then we also have a downward force on the tape A, which is the downward electrical force due to tape B. This doesn't end up having an effect on the overall system because we're holding it in place. So any downward force is counteracted by the presence of supports. So the line code ends up being similar. It'll be submitted. This is a generation of the forces. When we interpret the tape as a series of charged lines, you can see it's still very similar. The reason that bottom arrow is bigger is because it's actually the combined gravitational force and electrical force. I don't know why I combined them. I tried to figure it out and I could not. And then it's still vertical, completely vertical, even though technically we have a line of charges that should be interacting. But that's because any horizontal force exerted by, like, say, the atom on the far right is canceled out by by the horizontal force exerted by the atom on the far left. And overall, it'll cancel out, so it's still two completely vertical charges. Deficient electrons. So the number of deficient electrons is just going to be our total charge divided by the charge of the absolute value of the charge of an electron. So it's going to be 7.106 e to the 10 electrons. And then total number of atoms on the tape is just going to be surface area divided by the length of an atom squared, which I interpreted it as a like square unit of area. So it's going to be 4 e to the 17 atoms. So there is one deficient electron per 5.63 e to the 6 atoms. Now the what if. What if electrons are negatively charged and protons positively charged? That was incorrectly put on the script. What if they had a flipped charge? The only change this would make to the experiment is that the tape would react differently to the pen. So it would move away instead of being attracted to it necessarily. But the actual tape experiment wouldn't change because it would still be two like charge items repelled by the same force. Since protons and electrons have the same charge, so if you swapped them, they would still be pushed away the exact same amount. Why? So the charge for the line tape was slightly higher than the point charge. I believe the reason that it had a higher charge is that we calculate it with a greater charge accuracy, as well as there technically being an X component because it's a bunch of charges in a line. So it's gonna have an X component, which would increase the overall magnitude. I also think this is much more likely. This is much more likely closer to the real value, since a series of charged lines is closer to the real world approximation than just a singular point charge, since our tape has 3D dimensions. This is just basic assumptions we had. There was no air resistance. It was a point charge for the first experiment. They have the exact same charge, and the charge is completely evenly distributed. In conclusion, that's what the tape's charge would be in an ideal environment, assuming all the assumptions hold. The gravitational electrical forces are the same. This is not realistically true because likely the measurements weren't perfect, as well as the charge not necessarily being evenly distributed. There's also a likelihood that there's other charges present in the environment that we couldn't account for.